Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a single-mode fiber optic link using a fiber L4 bolt optical power meter and a WaveSource series single-mode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multi-mode. In the case of multi-mode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the fiber L4 bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multi-mode, this is 850 and or 1300 nanometers, and for single mode, this is 1310 and or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multi-mode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standards specifications. Refer to OWL's video on mandrels for more information. Okay, as you can see, we've gathered all the accessories that we will need for this test, and we've also gathered all our link information. As you can see, we've got 3 patch cables here, our power meter, fiber OWL power meter, and our WaveSource single mode light source. In fact, this light source has multi-mode and single mode wavelengths in it, but for our purpose we're going to use the single mode port here. See, it says SM port. Now you might ask, why are we using 3 patch cables if there are only 2 patch panels, one at either end? Well, the 3rd patch cable is used for the length measurement capability in the fiber OWL. Basically what you need is a patch cable for both of these ports, a transmit port here and a receive port here, but at the far end you need a 3rd patch cable to loop back to produce a a continuous loop for light to travel from the transmit to the receive port. So anyway, what we need to do is check all of our patch cables to make sure that they are okay for use. Now for single mode fibers, the target power value here we're looking for is approximately -10 dBm. It could be a little higher, a little lower, but it should be fairly close. First thing we need to do is to power on the equipment. And to do that on the fiber owl, the power button here is located at the bottom of the keypad in the middle here. So just press that one time. And then with the WaveSource, we'll see that we have a power button here, so we'll press that. Now with the WaveSource, you can see that it powers on the multi-mode port by default, but we're testing the single mode port. So what we'll do is we'll push the port button here. Port will change between the multi-mode port and the single mode port. So we'll press port to move the output wavelength over to the single mode side. Now, as you can see on the fiber owl, we've come up with an operating mode screen. Okay, we have simple meter, certification meter, and technical support options. For the purpose of checking our equipment, we will use simple meter. It's the easiest way of checking our patch cables. So we can see that simple meter is highlighted. We just have to press F2 for select. Okay, now you can see that the reading says under here. Now that's normal because we have the dust cap on. Under means that there is no light coming into the detector. When we actually take our measurements, we will not have the dust cap on. We'll be actually measuring regular light. So now that we have our equipment powered on, we will connect the first of our 3 patch cables. Now remember, we need to connect into the single mode port over here. So we'll do that on one side. And then the other side, we will plug into the detector port. You can see it says detector here. This is the receiver. For power measurements, you can't plug into this. This is a transmitter port. It will not take measurements. Only in this universal port, where it says detector, is where you take power measurements. So we'll take the dust cap off here, and then we'll plug in the other end of the patch cable. And as you can see, a number here appears that we don't expect. It says -5. The reason this is because we have 850 nanometers. Okay, so what we have to do here is switch our wavelength to 1310. See how you have the red circle here with a 1310 nanometers. That means the red LED is going to output 1310. In fact, if you use 1550, then the LED will be green. But what we need to do on the fiber owl here is press the F3 button to change the wavelength to 1310. We may need to press it several times. But now we can see that we have a power level that's closer to -10. Now this says -9.72. This is close, and as long as we're really not exceeding a -11 dBm, that particular patch cable is okay for use. So now that we've tested this cable, we've ensured that it's okay to use. We will disconnect it, set it aside, and continue on and test the other 2 patch cables. Okay. Now we test the second one. We just connected in the same way as we did before. Okay, -9.69. This patch cable is also good to use. And remember, it's always good practice to put the dust caps back on to minimize the amount of dust and dirt that start accumulating on the end faces here. So now we're testing the third patch cable. Okay. All right, -9.4. So these patch cables are all sufficient for use in our test here. So now that we are assured that our patch cables are good, we can begin the process of setting up the meter for a certification test. Okay, now that we've checked our equipment, made sure our patch cables are good, and our equipment is in proper calibration, it's time to enter all the link information that we gathered earlier, as well as zero out the power meter and light source. The way to do that is to be in certification meter. Now remember, we're still in simple meter here, so we simply press the done key to get back to the operating mode screen, and then we press F1 to move the selection cursor down to certification meter, and we press F2 to select. Okay, now at the start menu you'll see several options. The first one is called Link Wizard. Now the Link Wizard is the setup process. This is the where you will enter in your link information. So we'll press 1 to start the Link Wizard. Now the Link Wizard is going to ask you several questions based on the link that you will be testing that day. That link information is going to be stored in at a certain point in the memory here called a link. Now a link, as far as the fiber is concerned, is just properties of a group of fibers that have the same characteristics. So same fiber type, fiber length, number of connections, and splices. Since all the fibers in say it's a 6 or a 12 strand cable will all be the same, they can all use this same link position. As you can see, we have one highlighted here, fiber link number 1. So what we're going to do is we're going to press F2 to select that particular link. And as you can see, you are given the option of changing the name. So this is useful for changing the name for the particular company that you're doing the test for, or a particular location. For our purpose, we're just going to leave it at fiber link number 1. So when you're done entering the link name, we're just going to press done. The next screen shows the date of the test. Now this is very important to change. This is the date that will appear on the report. The nice thing about entering the date in is that if you want to set up the meter today for a test that you're going to be doing tomorrow, you can put tomorrow's date in and it's not going to affect anything. But what we're going to do today is we're going to put in today's date. And then if you need to put in special characters, you simply use the 0 key. Okay, now we have the date entered. We press done. In fact, anytime you enter data in this way, you will simply press done to continue. The next screen we see here is fiber standards. Now, fiber standards are simply a set of common rules that cabling standard organizations have developed in order to determine whether a link will pass or fail based on a set of parameters. Most of the time, you will use the TIA-568. That's the most common standard in the United States. However, there are other standards out there, specifically this ISO standard, which is used commonly in Europe. There are several Ethernet type standards, where if you know what type of Ethernet you're using, you can test that. Or there are user-definable standards for advanced users who want to develop their own TIA type link budget. But for our purpose today, we're going to just simply assume we're going to use the TIA-568 cabling standard. So once you can see we have it highlighted here, I'll simply press F2 to select. The next question you're asked is the fiber type. There are different loss parameters for different types of fibers. So what we have to do is we have to pick the type of fiber we're going to test that day. So since this is a single mode test, let's assume that it's an in-building network and we have all indoor single mode fiber. So you'll press F1 until you get to the right option and then F2 to select. The next question is, the fiber owl needs to know how long the fiber is in order to know how much loss to assign to that particular group of fibers. Now there are two ways of doing this. You can either enter the length manually. So if you know the length already, you can just type it in. It's a lot easier to do that. However, if you don't know the length, then the fiber owl has a feature where you can use the meter to measure the length. And I touched on this earlier in the video, but what I'll do is I'll demonstrate how to do that now. Now, for the length measurement, we will not need the WaveSource light source. So we can set that aside for now. But what we will need is the fiber owl and these 3 patch cables here. Okay, so the first patch cable you will need for the detector, the receive port. The second fiber you will need for the transmit port. And then the third patch cable, again, as I alluded to before, will be used as a loop back at the far end of the fiber. Now, what I've done here is I've made a simulated fiber link. It's in a little box here, but if you can use your imagination, you can pretend that there are two sides here. Like side A might be the far end of the link, and side B might be the near end of the link. So what you do is you pick two fibers out of this link. So let's say fiber 1 and fiber 2. Okay, one will be a transmit fiber, one will be a receive. Now it doesn't matter which is which as long as you have the two patch cables plugged into these two ports here. Now, once you have those connected in, you need to send somebody to the other end of the fiber, and you need to plug in this third cable as a loop on the same fibers that you used before. So fibers 1 and 2. So there's 1 and 2. Okay, now, so you can kind of picture that the light is coming out of this port here, traveling through the link, through this loop back, and coming back into this receive fiber. So, once you're connected, let's press 1 to use the meter to measure the length. Now, as you can see here, there's a screen that shows you, kind of describes how you need to do this length measurement. Just like we've connected it here before. So, a fiber pair required, 1 and 2, patch fiber A to fiber B at the far end of the link. But once we've connected in, we simply press F1, or we can press done here. So we'll press F1. And what's going to happen is the light is going to travel through the link. The time it takes to get around the loop is converted to distance and then cut in half, because all we're interested in is the distance from this patch panel to this patch panel. Now, in this case, it says 0 meters. That's simply because there's very little fiber in here, so it's rounding down to 0. However, let's just say that you have 325 feet of fiber. So what you want to do is you want to enter that length in manually. Now, normally, if you had 325 feet of fiber, it would say, for example, 100 meters here. But since we're going to enter it in manually, we can press F2 for done. And this is the screen where you would have went to if you entered the length in manually anyway. Now you can see that the screen says meters here. This means you're going to be entering the length in meters. But let's say you don't know how many meters it is, but you want to enter in feet. So if you press the F2 button, see it says units here, you press F2 to toggle. So pressing F2 toggles between feet and meters. Okay. Now what we're going to do is we're going to enter it in feet. So we need to backspace the cursor all the way to the beginning of the entry field, and let's type in 325, because that's how, let's say we have 325 feet of fiber here. So once we've entered that in, simply press done. Okay, now once we're done with our length measurement, we will not need this patch cable anymore, so we can disconnect it from the link and then set it aside. We will not need it anymore for this procedure. And again, it's always a good idea to replace the dust caps. Now these fibers here can be disconnected from your link. We'll set this aside for now. Okay. Okay. Okay, so these are the cables we will be using for our test. We can set those aside. We'll be using them in a few minutes here. Okay, now the next thing you're asked to do is enter the number of inline connections. And what I'm going to do here is I'm going to refer back to this simulated fiber link. A connection is simply a patch panel or a wall plate. Let's say you're in an office, somebody's office, and you're coming out of the wall with a fiber port. Well, that is actually a connection also. So you have either a patch panel in your equipment room, or you have a wall plate, or just another mating sleeve like this one. Okay, that is a connection. Basically, the connection is what you're measuring is the the gap produced between the two fiber connectors. So there's a fiber connector that could go in here, and then in the back of this patch panel here, there's another fiber connector. So that junction between the two connectors is what's being measured here. Now, since we have a typical fiber link here, we have patch panel on this side and a patch panel on this side. Okay, all 6 fibers have the same characteristics. You know, they have two connections, one on either side. So what we're going to do is we're going to enter the number 2 here, and then we press done. Okay, the next screen is asking us the number of splices. Now, most cabling standards allow you to have a certain number of loss per splice as well. In single mode, there is a good chance that the fiber could have been spliced on, either fusion spliced or with unicam connectors. Either way, those types of splices are covered by cabling standards, and you're allowed to have a certain amount of loss for those splices. So what we'll do, we'll assume that we have splices on both patch panels. So again, each fiber has the same characteristics on both sides, so each fiber has 2 splices. So we'll say 2 here, and then hit done. Now we have a review of our the data that we entered. Okay, if you can see that here, we have our cabling standard at the top. We have our fiber length, our number of connections, number of splices, our fiber type, and then we're asked if this is correct. Now, if it is, we simply press yes. If it's not, we press no and start over at the beginning. But since we're assuming this is correct, we're going to press F1 for yes. Okay, what this means now is we've entered the link information we gathered earlier. Now we have to zero out the equipment. And if you can see at the top here, it says set source references. This means set a reference or set a 0 or zero out your equipment. Now you can see there are 2 wavelengths here, 1310 and 1550. These are the 2 wavelengths supported by the TIA standard. What we're going to do is we're going to set a reference for 1310 first. So as you can see, as I press the F1 button, that the asterisk moved in front of the 1310. Okay, now the middle column here is the reference level in dBm. It says not set right now, which means we haven't set a reference yet. And -10 is the typical value. Remember what I alluded to earlier, is that we want our reference cables to read roughly -10 dBm. So what we do now is now we do need our light source, and we need one of our reference cables here. Okay. So what we're going to do is we're going to connect in the reference cable to the single mode port on the light source, and then again to the detector port again. Remember, we're not taking measurements here, only in the detector port. So we plug in there, and then once we've connected in, we press F2 for set. Okay. Now the fiber owl is going to warn you here. It says connect 1310 nanometer source. Okay, what that means is you have to make sure you have a patch cable connected between the single mode port and the detector port. And you also have to make sure that you are set to the 1310 nanometer wavelength here. Now, as you can see, the indicator LED right here is red, so that means we're set at 1310. We're ready to go. So, the other thing that the screen is telling you is says the source must be in CW or continuous wave mode. It means the LED is not blinking. What this means is that in order to set a reference, you have to be in what's called continuous wave mode. Continuous wave means the light is always on. It's not flashing on and off. If you see that this indicator LED is flashing, that means that the light source wavelength is also flashing. And I'll demonstrate that here. As you can see, there's a button here that says CW and mod. If I press that button, you will see what happens when I go to modulated mode. So modulating, it means it's flashing on and off. Okay, you can't take a reference off of a modulating signal like this. So what we have to do is make sure that the light is on solid. You know, once it's on all the time, now you can take a reference. Okay. Once you verify that your source is not blinking, you simply press F1 to continue. And then again, we have a fail-safe just in case you think you made a mistake, just to go back and double check, make sure you did it right. And then F1 to set the reference. Okay, as you can see, it says -9.57. That's a good reference. But let's assume we want to take two measurements for both wavelengths. So we simply press, change the wavelength on both units. Press F1 to move the asterisk down to 1550. And we press the lambda button here to switch to 1550. Now you'll notice it flashes briefly before it goes solid green. We'll be using or demonstrating that feature later on. It's called auto mode. But anyway, so now that we've verified that we are set to 1550 and the light source is on solid, simply press set again, and then F1 for done, and F1 for yes. Now you can see minus 9.83. That is a good reference level. So what we can do now is continue on. We're confident that we've set our references. Simply press done or F3 to continue on. Okay, once we've set a reference, we want to continue. It'll say begin taking readings. Well, we are ready to take readings, but the first thing we want to do before we disconnect any reference cables is we want to check just to make sure that our references are properly set. So we press F1 for yes, say we're ready to take readings. Okay, what we want to do here is make sure that we are reading at around 0.00, roughly 0. It could be a little higher or a little lower again, based on different environmental factors. Now, as you can see, it's not quite 0.00, but that's because we have our wavelengths are not synchronized, 1310, and here's 1550. What I'd like to do now is just take a minute or so to demonstrate what's called auto mode. Okay, auto mode is a way for the fiber owl and the WaveSource to work together to test two wavelengths at once. Okay, so on the fiber owl, it's very simple. You simply press auto. I'll say auto on, and you'll see that it'll switch between a wavelength and auto. Now, when you see this means that the fiber owl is scanning incoming signals for an auto testing signal. So it's looking for that flashing. Obviously, that's not happening right now, but it's ready to accept an auto testing signal. So what we're going to do is demonstrate how to set the auto testing signal in the WaveSource. That's simply done by pressing see if you notice here, there's a lambda/auto button. Okay, lambda, if you just press it one time, will switch the wavelength one time. But if you press and hold this button, that'll set the WaveSource into auto mode. And this is kind of tricky. It might take a couple times to get it right, but what you do is you press and hold the auto button until you see that this indicator LED begins to flash. Once you see it begin to flash, immediately remove your finger. So I'll demonstrate that now. Okay, now after a few seconds, you will see that the light source here will start alternating between red and green, and it'll go between flash and solid. Okay, this means that the WaveSource is already set into auto mode. Now, as you can see over on the power meter, you'll see that there's a reference level for both 1310 and 1550 on the screen at the same time. Okay, this is your assurance that your light source has been zeroed at both wavelengths. Okay, just to give you a little idea of what's on the screen here as well before we continue. You'll see that you see pass. That means you're passing the standard. You don't have enough loss to fail. You have your wavelength. You have that for both wavelengths here. And then you have your loss reading here in dB. You'll notice that Hz or Hertz shows up here. What that means is that that Hertz shows up when the auto testing flashing signal is coming in. The next number down here is the temperature. And percentage here is battery life. On the left-hand side here, you'll see you have your fiber link name, so fiber link number 1, and you'll see that it says new name here. This is where your fiber ID will show up. The reason it says new name is because we haven't stored any data yet. Over on the right-hand side here, we'll see our wavelength, and this will be corresponding with the wavelength that is currently being output from the light source. You'll notice that if it says 1550, that you'll see that the green LED is lit, for example. And then at the bottom, you see 3 menu options here corresponding with the 3 F keys. Okay, now that we've verified that that our link information has been entered and our equipment has been zeroed. We've verified that. Now we can go ahead and start taking readings. Now that we've set up our equipment and zeroed out our light source and power meter together, it's time to take measurements. Now, this can be done by taking the light source with its reference cable to one side of the link and the fiber owl with its patch cable to another side of the link. Now, one key thing to remember here is that you must keep the reference cable attached to the light source or the launch point. It doesn't matter if you disconnect it from the power meter, but if you disconnect from the light source, then you will have to re-zero and reset up your meter. So what we need to do is disconnect from the power meter here, and then we take the light source with its patch cable. Let's say this is to one side of the link, and then we take a patch cable that we set aside earlier with the fiber owl to the other side. And at this point, we can connect into the power meter detector port here. Okay, now each tester has its own patch cable, but what we need to do now is connect the testers into the link under test. And again, for our purpose, what I'm going to do is I'm going to use the simulated fiber link. So let's say side B is in one closet and then side A is in another closet. What we need to do is measure the loss from end to end. So the first thing we need to do is connect into fiber port number 1. And what we'll do is we'll connect in as such to port 1 on both sides. Okay. Now what we need to do, since the light source is still in auto mode, it will take a few seconds to have the fiber owl acquire the auto testing signal. As you can see, we have acquired it here. So we have a reading for both wavelengths here. Fortunately, they both pass, which is good. So we're satisfied with this result. What we'll do is we need to press F2 for store, and that will store the reading for us. Now, since this is the first reading that we've stored, we'll come up with a screen that says enter fiber name. And this is simply a prefix for the port number that we're connected into. So in this case, if we were to select the default value, FBR : here, the fiber owl will automatically append the number 1 to the end of that. So, and you can name this, this prefix whatever you want. For our purpose, we're going to leave it at the default value. So when we've done changing or entering this prefix here, we press the done key, and you'll see our results here. We'll see that they're both passes. Here's the wavelengths, and you can see here is the fiber number, fiber : 1. Once we're satisfied with this result here, we press F3 for save. Okay. Now, since we've tested fiber number 1, the fiber owl automatically appends the number, or increases the number by 1, and now it says fiber FBR : 2. What this means is that the fiber owl is ready to store port number 2. So what we're going to do is we're going to connect into port number 2. Okay, and then we wait a few seconds for the auto testing signal to take effect. And as you can see, we have another pass reading here. So we're going to store this reading and then again save it. Now, to speed up the process, I'm gonna store these readings very quickly here. And finally, we connect into port number 6. We wait for the auto testing signal to take effect. And here again, we see we have pass reading. What we'll do is we press store and save again. And what we have done is we've stored reading for all 6 fibers in this link. Now, as you can see, all of these fibers have passed. So this is a good link. So now we've stored all the data, We can take the power meter to a PC and download the test results to produce a certification report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Once the test results have successfully been downloaded, the data will appear in the OWL reporter screen. The test results can be viewed in two different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.